Okay, today is 5.3, addition and subtraction of rational expressions. Alrighty, so to add or subtract rational expressions, the expressions must have the same denominator. As with fractions, we add or subtract rational expressions with the same denominator by combining the terms in the numerator and then writing the result over the common denominator. This is then, if possible, we simplify the expression to lowest terms. So we see here, if we have p over q plus r over q, right, we have the common denominator, so we just simply add the numerators together, p plus r. Same thing here with the subtraction sign. We have the common denominator of q, so we do p minus r. All right, so example 1A, it looks like we have a common denominator of 8, so we can just simply say 1 plus 3 over 8, so 1 plus 3 over 8, or in other words, just simply 4/8, or in other words, 1/2. Okay. Excuse me. All right, so that's A. B, looks like we have that common denominator of 2x minus 1, so we can just simply say 5x plus 3 over 2x minus 1, and I guess that's it. There's nothing that can be done. It's already in lowest terms, right? And then C, let me just make sure that's fair. All right, well, I guess I'm always scared to be tricked here, right? But anyways, so the C looks like x squared, and it looks like now it's a minus the entire numerator on the right side, so minus x plus 12, okay? And then that's all over x minus 4. Now, don't make the mistake of just saying minus x plus 12 like that, because that obviously is just a negative x plus 12. That is not the case here, right? It is minus x, the quantity of x plus 12. Okay, and if I subtract the quantity of x plus 12, then that's going to turn into x squared minus x minus 12 all over x minus 4. All right, and I'd venture to say that the numerator factors into some form of x minus 4, right? Because I mean we're probably going to be canceling here. So it looks like x minus 4 and looks like an x plus 3. So x minus 4, x plus 3 all over x minus 4, and then the x minus 4's cancel. So we're just left with x plus 3, right? And that is simply adding and subtracting my and subtracting rational expressions with like denominators. Okay, when they're with when they are like denominators, they're pretty easy. However, we'll see here in a moment how it just gets way worse. All right, so we're gonna talk about the least common denominator here. All right, so when we have the least common denominator of a function, it's the smallest number that both numbers can go into, if that makes sense, right? So, how can I word this? I mean, I don't want to just read it off. Instead, what we'll do, we'll just do it the way I like to go about things, and just kind of just do it and talk, right? I get paid to talk, so we'll talk. So example 2, A, find the least common denominator of the rational expressions. Okay, so A admittedly is probably going to be one of the harder ones that we do. All right, because whenever we start talking about our polynomials and stuff, they're actually pretty easy to spot. But pay attention to how we get A, and we're going to be doing that procedure the rest of the time, essentially. Okay, so we need to find the least common denominator of 12, 18, and 30. So we're saying what is the smallest number that all three of those numbers will go into. Okay. Now, again, like I said, the, when we get to the actual rational expressions, the numbers are going to be a lot easier. I promise you, because well, I've done this before. I've seen this before. This problem is a little bit difficult, but it's not difficult. It's tedious. Okay, so let's go ahead and start, and I'll shut up. So what we need to do is we need to find the prime factorization of these numbers. Okay, so if you recall, getting prime factorizations, right? There are multiple ways to go about them, but one of them is doing a prime factorization tree, right? So 12 can be 2 times 6, and the 2 is a prime number, so I'll stop there. My 6 is a 2 times 3. Both 2 and 3 are prime numbers, so I can stop there. Okay, 18 is 2 and 9, so I can stop at 2, and then I've got 9, right? 2 times 9 is 18. Oops, I didn't mean circle 9. And then 9 is 3 and 3. Okay, so we can stop there. And then 30 is 2 times 15. Again, 2 is prime, so I can stop there. And then 15 is 3 times 5. Both those are prime, we can stop there. Okay, so this is the prime factorization tree of 12, 18, and 30. So what do we do with this? Okay, so what we're going to do is we're going to write the prime numbers, right? So 12 is 2 times 2 times 3. Or in other words, 2 squared times 3. 18 is 2 times 3 times 3, or in other words, 2 times 3 squared. And 30 is 2 times 3 times 5. Okay, so here's what we're going to do. Looking at the prime numbers, okay, what prime numbers are we using? We're using the prime numbers 2, we're looking at the prime number 3, and the prime number is 5, right? We have a 2 here. I mean, obviously I have 2 here and 2 here, right? But I don't have to repeat that for right now. I'm just looking at what prime numbers am I using. I'm using the prime numbers 2, 3, and 5. Those are the only prime numbers that I'm using in my prime factorization. Okay. So now, what is the highest power of 2 that I'm using? Well, the highest power of 2 I'm using is squared, right? This is to the first power, this is to the first power. So the highest power of 2 that I'm using is squared. What is my highest power of 3? Well, that's also squared. And what is my highest power of 5? Well, that's just 5. Okay, so we would say 2 squared, 3 squared, and 5. So let's put these a little sideways here. 2 squared times 3 squared times 5. Okay, well, 2 squared times 3 squared times 5 is equal to 4, 9, 36, 180. Okay, so 180 is my least common denominator of my denominators 12, 18, and 30. All right, now that process, right, was pretty tedious for this particular example, but like I said, it does get a little bit easier, but that process that we did is how we're going to find the least common denominator of expressions moving forward, looking for highest powers. Okay, and of course I will point it out every time that we do it. All right, now B, we have looking at my denominators, 2x cubed y and 16x squared. I'm sorry, 16x y squared z. Okay, well, what is the smallest number that 2 and 16 will go into? Well, that's easy. That's just 16. Now I have an x cubed and an x. What's the smallest power that x cubed and x will go into? Well, that's x cubed. Y, what's the smallest power that y and y squared are going to? Well, y squared. And what's the smallest power that z can go into? Well, there is no z, and there is a z, so it'd be z. So I'm just looking for essentially my highest degree. Again, that's what I did. If you recall, that's what I did over here. I looked for simply my highest degree, and then of course 5 to the first power, and that's what I did. 2 squared, 3 squared, and then 5 to the first power. So again, like I said, that same procedure is what we're doing here. My highest power of x was 3, my highest power of y was 2, and then my highest power of z was 1. Okay? And so that's how we found the least common denominator there. More least common denominators. So find the least common denominator of the rational expression. So it looks like I'm going to have to factor my denominators here. Okay, so if I factored the denominator on the left, it looks like I can factor it into 5 and a 4, so x plus 5, x plus 4. That's the denominator of the left side. And the denominator of the right side, the right fraction, looks like it can factor into, looks like it's a 4 squared, looks like it's a perfect square trinomial. Okay, so those are the denominators of both of my, of an A. All right, so what is my greatest common denominator? Well, it looks like I have an x plus 5 as one of them. Okay, so x plus 5 is definitely one of them. All right, and then the next one, I have an x plus 4 and x plus 4 squared. Okay, so those factors are the same. So what I'm looking for is the highest factor of it. So squared is going to be my highest factor. Okay, and that's A. And B, well, it's kind of, B could be either. So I have an x minus 3 and then a 3 minus x, right? And in both of those cases, um, it could be either x minus 3 or 3 minus x because they're the same. It's just they are they are only separated by a factor of a negative 1. Okay, so the least common denominator here is going to be either x minus 3 or 3 minus x. Um, that's it. They're again, they are the negatives of one another, right? This well, y'all can't see my mouse. This one has a positive x and negative 3. This has a positive 3 and a negative x. And we saw in the previous example that you can factor out negative 1 and pretty much change it to the other one, right? So that's why this particular example can use both of them. And honestly, let's see, let's go ahead and put that. Okay, sometimes I'm at a loss of words. I won't say a loss of words, but you know, I'm not as eloquent as these authors are. So we're going to put that right here on the notes. All right, equivalent rational expressions. Okay, so we've done problems before with writing equivalent fractions, and that's all we're doing here. Is we're trying to figure out um, what the equivalent fraction is, and of course we have to do this in order to get to the next part of this section. So let's look at A. So it's 7 over 5p squared, and it's equal to something over 20p to the 6th power. Okay, so looking at my denominators here, how do I go from 5p squared to 20p to the 6th? Well, it appears that I multiply by, it looks like I multiply by 20 divided by 5 is 4, so it looks like I multiply by 4, and p squared to p sixth looks like p to the 4th. Okay, so it looks like I multiply the denominator by 4p to the 4th. Right. Well, whatever I do, excuse me, whatever I do to the denominator, I must do to the numerator. And honestly, let's change the orientation there. It looks like we'll do it this way. What I say, 4p to the 4th. Looks like I multiplied the denominator by 4p to the 4th. Well, whatever I do to the denominator, I must also do to the numerator, right? Otherwise, it's not going to be equal to 1. So 7. So 7 is in my numerator, right? So I need to multiply 7 by 4p to the fourth. So, and that would get me 28p to the fourth, right? So that's A. B looks a little more intimidating, right? So how do we get from w to the fifth to w squared plus 3w minus 10? Okay, well, it looks like it's a quadratic equation, so let's go ahead and factor it. Okay, so let's go ahead and factor w squared plus 3w minus 10. Okay, it looks like that factors into a w. Uh, I'm sorry. All right, so I'm trying to figure out how to get from w plus 5 to w squared plus 3w minus 10. And in order to do that, I'm going to factor out w squared plus 3w minus 10. Well, what are my factors of 10? Looks like 5 and 2. So it looks like a negative 5 and a positive 2. So it looks like it's going to be, I'm sorry, a positive 5. W plus 5, w minus 2. Okay, so that is the quadratic here. Right. Well, B again is we're trying to get from w plus 5 to w squared plus 3w minus 10. Well, how do I get there? Well, it looks like I need to multiply by w minus 2. Okay, so it looks like I need to multiply by w minus 2. So if I multiply the denominator by w minus 2, then I must multiply the numerator by w minus 2. So w, and then following along the same color path I did in my numerator, times w minus 2. Well, that would get me well, honestly, I don't suppose I have to distribute here. Right? So that's it. Let's see if the textbook actually distributed. Okay, they did distribute, so let's go ahead and distribute as well. Same thing as w squared minus 2w. Okay. Addition and subtraction of rational expressions with unlike denominators. Now we're getting to the fun stuff. And by fun stuff, I mean not fun stuff. Okay, so in order to add and subtract rational expressions, all right, so let's look over here to the left. If we have 3, yeah, it's kind of hard to see, I guess, but 3 divided by x minus 2 plus 5 over x plus 1. We want to add these two rational expressions that have unlike denominators. Well, in order to do that, we must get them to have a common denominator. And this is where we tie back into finding our least common denominator that we did on the I don't know, examples 1 and 2, I think. Right? So we have 3 over x minus 2 and then 5 over x plus 1. Well, what is the least common denominator of x minus 2 and x plus 1? Well, it's just simply x minus 2, x plus 1. So what I have to do is I need to multiply this fraction, x minus 2, times x plus 1 over x plus 1, because again, that's equal to 1, because I'm not changing the value of the fraction, right? And anything over itself is 1, so I'm not changing the value of the fraction, but I'm choosing x plus 1 over x plus 1 because I need to multiply the denominator by x plus 1. I don't care what I multiply the numerator by. I mean, the numerator is going to be whatever it is, whatever we follow along with, we're here in the denominator. But I have to do that with this term on the left and the term on the right, x plus 1. How do I get the denominator on the right to have a denominator of x plus 1 and x minus 2? Well, I have to multiply by x minus 2. But I can't just multiply the denominator by x minus 2. I have to multiply the numerator by x minus 2 as well. Okay. Now, this nice, pretty laser pointer doesn't help too much. So let's actually get to an example. Alrighty, we have one job, add. Just simply add. But this is a good example to start off with because, well, let's write this nice and large here. We have 3 over 7b. We're going to put a little space there so I can do some computation. All over 4, oh, I'm sorry, plus 4b squared. All right, looking at my denominators. What is my least common denominator? Okay, well, looking at them, I have 1, 7. Okay, so I have a 7. And then I've got a b. Okay, well, what is my highest power of 7? Well, that's easy, it's just 7. And what is my highest power of b? Well, it's squared. So 7b squared is going to be my least common denominator. So what I need to do is multiply by something to get to 7b squared. Okay, so how do I turn 7b into 7b squared? Well, it's already got the 7, and it already has 1b. So I must multiply it just by b. Multiply the denominator by b. Okay, but if I multiply the denominator by something, I must also multiply the numerator by that same something, because I can't change the value of that fraction. If I were just to well, we'll just do my age, right? So I'm 35 years old. I'm 35 years old. Okay, and that's 35 over 1 as a fraction. If I wanted to multiply my age and have a b in the denominator, right? This is a stupid example. Well, I wouldn't just say I'm 35 over b years old, right? I would say 35b. Oh, that's a dumb example, Sherman. But hopefully you get my point. Like, by multiplying something over itself, I'm multiplying by 1. I'm not changing the value of my age at all, right? Because 35b over b is just simply, well, heck, let's flesh this out. 35b over b, and then the b's cancel, right? So I'm still 35 years old. So I'm multiplying by 1. I'm multiplying by 1. It's a clever one, but I'm multiplying by 1. I'm not changing the value of my age at all, right? So let's try a different example. Let's do 35 times let's do smiley face over smiley face. Okay, what is 35 times smiley face over smiley face? Well, anything over itself is just 1. Doesn't matter what the value is, right? Heck, let's get crazy, right? Let's get crazy. Let's say alpha over alpha, right? Again, hopefully my point's made. I'm multiplying by 1. I'm not changing the value of anything. So that's what I'm doing here. I'm multiplying by 1, b over b. Well, I think I spent enough time on that one. Let's move over here. We have 4 over b squared. Okay, so how do I turn this denominator, b squared, into 7b squared? Well, it looks like I need to multiply it by 7, right? So we're going to say multiply this by 7. But again, I can't just multiply the denominator by 7. I must also multiply the numerator by 7. Okay, and then by doing this, we end up with, we'll put a little arrow here to kind of show the progression here, 3b over 7b squared plus 4 times 7 is 28, 28 over 7b squared. Right. Well, my denominator is now the same. I have a common denominator, so I can simply write my common denominator there. And my numerator is 3b plus 28. Right? And that's it. That is how we go about doing it. Now, this is a rather easier example, but I want to spend a little time on it to really drive the point home that I'm not multiplying it by anything different. I'm just multiplying it by 1. Now, oh gosh, I think there's 9 examples here. Ooh, okay, now we're going to get to the very not fun part. The part that made me not want to wake up this morning. Just because, I shouldn't have said that. That kind of scares you, doesn't it? It's not hard. It's just tedious, and I think I've given my spiel on hard and tedious already in this class. If I haven't, you're spared. If I have, I'm sorry. But let's proceed. Okay. So first thing we need to do is we need a factor. So let's go ahead and rewrite this, but with my polynomials factored. So the numerator on the left is already is good to go. It doesn't need to be factored. 3t minus 2. The denominator, it looks like it factors into, looks like a plus 6 minus 2. And then minus, and then it appears, well, let's actually give it a big space like it did on the previous example. And then I can factor a 2 out here, so I got 2 and then t plus 6. Okay. So my least common denominator, we're going to put it up here in a different color. Least common denominator is, it looks like, so I look at factors. I have a t plus 6. Okay, so a t plus 6 is one of the least common denominators. T plus 6. At t minus 2. T minus 2. A 2. And then at t plus 6, but I've already said t plus 6, so I don't have to rewrite it. Okay. Now what I'm going to do is I'm going to go back and say, okay, so what is the highest power of those factors? Well, what is the highest power of t plus 6 that I see? Well, it's just the first power and the first power, right? So nothing extraordinary there. The highest power of t minus 2, well, again, first power, that's it. And my highest power of 2 is just 2. So that is literally just my least common denominator. My least common denominator in the blue. Let's go ahead and put the 2 out front, because I know that we like to put our constants out in front like that. So let's put the 2 out here. 2, that's the least common denominator. Okay, so how do I transform this denominator into this? Well, it's already got the t plus 6, it's already got the t minus 2, it does not have the 2, so I must multiply it by 2. And then multiply the numerator by 2. Okay. What do I need to multiply this by to get to this? Well, it already has a 2, it already has a t plus 6, but it needs a t minus 2. Okay, so it needs a t minus 2. Perfect. So now let's do the arithmetic here. So the left side looks like it's just going to be, it's going to be 2 times 3t minus 2. And then my denominator, again, is going to be my least common denominator, which is what I'm wanting. And then it's going to be minus 5 times t minus 2 all over 2 t plus 6 t minus 2. Okay, and let's snip this and put this on the next page. So we can now combine this. So we can combine this and we'll get 2, 3t minus 2. And it's going to be minus, and again, we'll put this whole thing, we're not going to use parentheses, we're going to use brackets this time because we already have parentheses in the numerator, and that's that's the difference between parentheses and brackets, is you just use one or the other if the other one's already being used. And then my common denominator is 2t plus 6 over t minus 2. Okay. Let's snip this. Oh gosh. Again, this is why I didn't want to wake up this morning. So now let's kind of finish this off a little bit. We can say, let's go ahead and distribute this 2 over here. We're going to go ahead and distribute the 2, so we're going to have a 6t minus 4. We're going to distribute this negative sign. Well, let's actually, before we distribute the negative sign, let's go ahead and do this minus, and we're in parentheses now because we're going to do 5t minus 10. And we're going to snip this again. Oh gosh. Okay, so it's going to be 6t minus 4 minus 5t, and then plus 10 all over 2 t plus 6 t minus 2. Okay, so it appears um, we can combine some like terms here. So we're going to have a 6t minus 5t. That's going to be t. And then negative 4 and a positive 10 is going to be plus 6 all over 2t plus 6 t minus, let's fix that up, t minus 2 and t plus 6 and t plus 6, they cancel. So I end up having, let's put this up here. It's a little weird, but we're going to put it up here. I'm going to end up having 1 over 2 t minus 2. And that's it. I say that's it, but you guys see how it gets pretty tedious pretty fast. That was example 6. We have 3 more. That doesn't look terrible. It looks horrible. Who am I kidding? All right, so this time it looks like we have 3 terms. Oh no. Bad news. So let's go ahead and write this problem with factored denominators here. Yes, not too much has to change. So we've got a 2 over x plus, yeah, not much has to change at all. Just basically the last one. Hang on a second. If I'm going to, let's actually proceed with this problem the same way I've done before by leaving a little bit of a gap in between. Although, what will my least common denominator be? X and x plus 3. Okay, so it's not a big least common denominator. And then minus. And we could factor the numerator, but we're going to keep the numerator as is for right now, because right now we're just trying to factor my denominators, get a least common denominator, x and then x plus 3. All right. Actually, you know what? Let's actually do this. I want you to get into a habit of factoring constantly. So let's go ahead and factor a 3 out. So we have x plus 6. We're going to go ahead and factor. We're going to factor my numerator there. Alrighty. So my least common denominator, right up here, least common denominator is, okay, so I have an x. Got it. I have an x plus 3. Got it. And then I have an x, which I already said, and I have an x plus 3, which I've already said. Okay, that's pretty easy. All right, now I'm going to look at my highest power of those numbers. Well, what's my highest power of x? Well, that's just 1, first power. Highest power of x plus 3, again, just 1, just 1, x plus 3 raised to the first power, and x plus 3 raised to the first power. So my least common denominator is just simply x times x plus 3. So I need to multiply this by x plus 3 over x plus 3. And I'll need to multiply this by x. And the last one, I don't have to touch it at all, right? I mean, it already has my least common denominator, x times x plus 3. Okay, so proceeding here, I'm going to have a 2x plus 3 all over x plus 3 plus x squared over x plus 3, and then minus, honestly, I should not have factored that. I'll show you why here in a moment. So let's snip this and put it on the next page. Okay. So we can now combine all of this into a single numerator over denominator. So let's go and distribute through, and we're going to do this because we're probably going to have canceling terms. Okay, so I'm going to go ahead and not factor, I'm going to go and distribute here, and I'm going to distribute here as I do my computation. So we're going to have 2x plus 6, and then it's plus x squared, which is right here, plus x squared, and it's going to be minus, and we're going to put in parentheses, minus 3x plus 18. Okay, and again, this subtraction sign is very important. Okay, because we're subtracting everything in the parentheses there. All right, and it's all that over x plus 3. Okay, now let's go ahead and just kind of help with, well, no, we'll keep that there actually. We'll keep it there. Same thing we did on the previous example, previous page rather. No, previous example. We're going to do this. So we'll have a 2x plus 6 plus x squared minus 3x minus 18 all over x plus 3. All right, and then we're going to rewrite this. Let's write it in descending form. So in descending form, we have x squared, and then x, we have a positive 2x and a negative 3x. We're going to have a minus x, and then a positive 6 and negative 18, so a minus 12 all over x plus 3. All right, we can factor x squared, we can factor the numerator here, and it factors into, it looks like it's going to factor into a negative 4 and a positive 3. Minus 4x plus 3. Obviously my x plus 3's look like they cancel, so I'm left with x minus 4 all over x. Ugh, it's awful. Awful stuff. I know the pain you're going through. I had to do it. Which one are we at? Example 8. Okay, so this one's pretty good because we just need to multiply by negative 1. So this is basically what we did in the, I think it was the last example of the last section, right? So we're going to have a 6 over w minus, and then we have a 4 over negative w. So we need to get a common denominator. What is my common denominator here? Well, it can be either w or negative w. Right? If you recall, that was the options on the last example of the last section. Well, I don't know about you guys, but I like dealing with positive numbers way more than negative numbers. So let's deal with a positive w. So I need to multiply this problem by, let's make it blue, negative 1 over negative 1, right? Negative 1 over negative 1 is indeed a positive 1. So I'm not changing the value of anything. So this turns into 6 over w minus, well, negative 4 times negative 1 is a negative 4, and then a negative w times a negative 1 is a positive w. Okay, and then we can proceed. Well, 6 minus a negative 4 is simply 6. Well, let's actually write it. Sometimes I get ahead of myself and I like to take shortcuts, but sometimes I shouldn't, right? So 6 minus negative 4, that's just 10. 10 over w. And that was a nice refreshing change of pace from the previous two problems. And this is more the same, but we'll still do it. It's just instead of having a single denominator, we're going to have a binomial. Okay, so what is my common denominator here? And again, it doesn't necessarily matter which denominator we choose. We're multiplying by negative 1 in either case, right? Because notice how both denominators, they are indeed negatives of one another, right? One has a positive x, one has a negative x, one has a positive y, one has a negative y. So we're just going to go with the first denominator being my common denominator. And then times -1 over -1. Right? And again, in doing that, I'll end up with x squared over x minus y plus, we're going to have a negative y squared all over x minus y. Okay, so I got my common denominator, so it's going to become x squared minus y squared all over x minus y. Well, x squared minus y squared, that's a difference of squares, right? So it's going to be x plus y, x minus y all over x minus y. Well, my x minus y's cancel, so my solution is just simply x plus y. And that concludes, chapter 5, section 3.